Hello viewers, I am Kausalya. Today we are going to solve problems related with maximum power transfer theorem. The problem is, in the circuit shown in figure, find the value of ZL for maximum power transferred to it. If two conditions are given, the first condition is if ZL is a pure resistor. Then the second thing is if ZL is a complex impedance with both variable real and imaginary parts. Determine maximum power in each case. So here this is our given circuit diagram. The value of ZL is not given. In the first case we have to assume the value of ZL as a pure resistive one, and in the second case we have to assume the value of ZL as a complex one. Right. So here when you consider the first case, right, ZL is a pure resistor. So in this case you see here we are going to, when you apply this maximum power transfer, what is the basic condition? The maximum power transfer will transfer to the load, right? It will get transferred here only when the value of the source impedance is equal to this ZL, right? That is the main condition. So here in this case the value of ZL is said to be purely resistive, right? But what about our source impedance? Here it is a complex impedance. We are having a resistor as well as an inductor here. Therefore, to find the value of resistance, that is load resistance, here we are considering the magnitude, right? So the magnitude of the source impedance, it is nothing but our 5 plus j10. So to calculate the magnitude, we have to square and take the square root. Therefore, square root of 5 square plus 10 square, that gives the answer as 11.18 ohms. Now we have calculated the value of RL, that is ZL here. So the next step is we are going to calculate the current, right? So we know the value of source impedance, we know the value of this load resistance. So here the thing is I is given by V by Z. So V, it is given here, that is 100 with an angle of 90 degrees, and Z is this plus this value. So here it is 5 plus J10 plus 11.18. Once you solve here, finally we are ending up with the answer like this, right? Again, you see it's up to you. Here I have converted this polar form to rectangular form, right? If you need, even you can convert this rectangular form of denominator to polar form. It is up to you. Anyway, calculator is going to do that. So do it carefully, right? Now, finally I am converting this rectangular form to polar form because here the reason is the power is given by this formula I square R, right? To find the value of I, you see, if it is in polar form, we can directly take the magnitude. Therefore, here I have taken this value of I and the value of RL. The value of RL, it is given as 11.18 ohms. Right. So just substitute it over here and the answer is 309 watts. So in case if the value of this load impedance is purely resistive, what is the maximum power that will get transferred? It is 309 watts. Right. So first part of the problem gets over here. The second part is, if ZL is complex, then we have to calculate the maximum power, right? If the ZL is complex, then we have to assume the complex conjugate of the source impedance. So here what is the complex conjugate of the source impedance? It is 5 plus J10, right? When you look at the problem, you see the value here is 5 plus J10, right? So the complex conjugate part is, it is 5 minus J10, right? So again the value of I is V by Z and the value of Z here is source impedance is 5 plus J10 and the load impedance is 5 minus J10. So just write it over here, and once you solve, the answer is 10 with an angle of 90 degrees. Again when you calculate power, it is I square RL. You know the value of I, the value of this RL, because again here we have to consider only the resistive part, right? So the value of R is 5 here. So just substitute it and finally the answer is 500 watts, right? Now we proceed with the next problem. Find the maximum power transferred to the load ZL of figure shown below. So here you see, this is the given circuit diagram, right? Here we have to again find the maximum power transferred to this load impedance ZL, right? So here the step is we have to find Vth and Zth. So how to find Vth? The thing is we have to remove this load impedance for calculating the Vth. You see, after removing the load impedance, our circuit looks like this. And here I am assuming a current direction by myself, right? So the first step is I am going to calculate the current that flows through this circuit. So I is again given by V by Z. So you see here the source is, the current direction is minus to plus, therefore this is considered as a positive source, and here it is plus to minus, therefore this is considered as a negative source, right? Again I have converted this polar form to rectangular form in the initial step itself. So this is your source divided by impedance. So here the impedance is 5 plus j5 plus 3 minus 4j. So just substitute it, and once you solve, here we are ending up with the answer like this, right? And the next thing is, that is the ultimate aim is to calculate the Thevenin's voltage. So Thevenin's voltage can be calculated in two ways, right? Either you can take this path to find this VAB, or else you can take this path to calculate the voltage across AB, because it is in the middle, right? Either you can take this portion or you can take this portion. Here I have considered this part. So we know the value of current that flows, right? Therefore it is easy. So here this V, I need this one, right? So this is the circuit. This is your source voltage. So you see the source voltage minus voltage drop. Voltage drop is nothing but it is I into R here. So this is your value of I, and what is the value of R? R is 5 plus J5, that's it. So just substitute the values over here, and finally the Thevenin's voltage is this one, right? Here the next thing is finding Zth. So in order to find Zth, we have to remove all the voltage sources, right? So once the voltage sources are removed, and even the load impedance should not be present. So here when you look at this node, what happens? You see the current gets divided, right? Therefore this branch and this branch are parallelly connected, right? How to find Zth then? Z1 into Z2 divided by Z1 plus Z2. So here Z1 is 5 plus J5, and here Z2 is 3 minus 4J, right? So Z1 into Z2 divided by Z1 plus Z2. So just substitute the values over here, and finally the value of Zth is this one, right? So again when you convert this into polar form, we will be having expression like this. Now again, in order to have maximum power transfer, what is the condition here? That is the Zth should be the complex conjugate, right? Therefore here our value of Zth is, that is maximum power will be transferred to the load only when the value of Zth is like this. Therefore just take the complex conjugate of the previously obtained thing. So here this is your Zth, right? Now to find the value of I, it is nothing but V0 by Zth plus load impedance, right? So just substitute the values here, and finally the value of current is calculated as 2.318 amps, right? Now to find the load power, it is nothing but I square RL. So here this is the value of I, right? And the value of RL is, we have to consider only the magnitude, right? So what is the magnitude part here? It is 4.384, that's it. So just substitute it over here, and finally the answer is 23.37 watts, right? Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.